Hello friends, hope your preparation is going well. Sorry for the delay in uploading the videos. So in this video I am going to discuss about how to calculate tractor center of gravity and tractor moment of inertia. Okay, so I know that you all are already aware about the formulas which is being used to calculate tractor center of gravity and moment of inertia. But what I will do in this video is I will try to derive those formulas and I will try to explain to you how those formulas are being derived. Okay, so moving ahead, this is about me. And so the first thing is center of gravity determination of a tractor. Okay, so the first thing first is what is center of gravity means. As you all know that for any solid body, for simplification for mathematical simplification, we assume that its mass is being concentrated at a single point, even though actually in reality this is not actually true. But in physics we assume that complete mass of that solid body is being concentrated at a single point. Okay, and that point we call it as center of gravity. So in case of tractor also, same thing happens. We assume that whole mass of tractor is being concentrated at a single point, and that point is known as center of gravity. So what do you mean by center of gravity determination? So basically we try to find out the location of center of gravity with respect to rear axle center. So you have to find out the horizontal location of center of gravity from rear axle center, as well as vertical location of center of gravity with respect to rear axle center. So if you got the coordinates of center of gravity, it means that you have determined the center of gravity, and that is what we are going to see how it is coming. So there are different methods of center of gravity determination of a tractor. The first one is suspension method. In this, what we are doing is we will just suspend the tractor with the help of rope or chain along a point, and then we try to find out its its balance. We will try to balance it, and with the help of that we will try to find out CG location. Okay, but this method is not much in use. This is actually, you can say, it's an obsolete method. Okay, now second method is balancing method. Now this balancing method is basically used for track type tractor. I hope that you all are aware about track type tractor. If you are not, then just search on Google track type tractor and you will find plenty of images and information about track type tractor. Basically what is happening in track type tractor is, instead of rubber tires, you will put tracks. Okay, those tractors will be very high HP tractors, 300, 200, or even more than 300 HP tractors. Okay, now the third method is weighing method. Okay, this is what we are going to discuss today. So weighing method is a most common method which is being used for determination of center of gravity of the tractor. Okay, so we are going to see how this weighing method is being used. Other two methods, you can read any standard textbook, you will find these are the simple theories. Okay, as I have already told you that what you mean by center of gravity determination is you have to see the horizontal position of rear axle, horizontal position of center of gravity from rear axle center, as well as vertical position. So for horizontal position, this is the basic representative figure in which you can see that this is a point where tractor center of gravity lies. Okay, so you have to calculate the location of the center of gravity from rear axle center, which is a small l, and vertical location of center of gravity from rear axle center, which is small h. So basically you have to find out what is l and what is h. So if you have watched my previous videos, then you are aware about all the terms which is being written in this figure. So wt is the weight of tractor which is acting downward at CG location. RR is the rear axle or rear tire support. RF is the front tire support. L is the wheelbase. Okay, in my weight distribution video, I have already explained to you how to balance the forces and how to take moments. Okay, so if you take moment about this point, then this RF will try to rotate the tractor in anti-clockwise direction. So the moment will be RF into capital L, and this wt will try to rotate this in clockwise direction, and this will be wt into a small l. So rf into capital L will be wt into a small l. From there you can derive a small l. So this is the basic equation. So this is very simple. So the horizontal position of center of gravity is very simple to determine, and it can be determined like this. Okay guys, so I hope you understood this. Now moving ahead, next thing is vertical position of center of gravity from medial axis center. That is a bit tricky. In that case you have to lift the tractor by a certain amount. Okay, now once you lift the tractor, then it's this center of gravity point will shift. Okay, so if you are lifting it in upward direction, then center of gravity will also shift in upward direction. Okay, then this wheelbase will also change, the small l will also change with respect to new center of gravity, which we are going to see. Okay, so moving ahead, this is the vertical position of center of gravity from medial axis center. So basically you have lifted the tractor by an amount which I have already explained to you, that you have to lift the tractor. So suppose you have lifted a tractor by this n amount. Okay, and I forgot to tell you that in all the cases in weighing method, you can see here you have this weighing scale on which you are measuring this RF. So actually you are measuring this RF on this weighing scale. So you know the RF, you know the total weight of tractor. Already manufacturing people or companies are giving the total weight of tractors. You know the wheelbase also. So you know RF, you know WT, you know L, so you can calculate a small l. Okay guys, so moving ahead, for vertical position of CG, this is the figure. So I will explain all the terms. Just listen very carefully what I am saying, and just try to see my cursor where it is moving. So we have lifted this front tire with this n amount. You already have weighing a scale placed over here. So now you can again measure the change in RF. So the new RF we have noted it as R dash F, and old RF was simply RF. Now similarly the rear axle support will also change, R dash R. Again this wheelbase will also change. Now this is L dash. Actually the wheelbase will not change, because what is happening once you have lifted a tractor, this is your actual wheelbase. Okay, the rear axle center line, then from this line up to this front axle center. So this is your actual L, but this L dash, this horizontal distance is now L dash. Okay, similarly the horizontal location of CG, this point, if you are watching this video, then I hope that you are able to see my cursor. Okay, so the point where I am placing my cursor, this is the original position of center of gravity in first condition. Now now when you have lifted the tractor, then the CG position has shifted from this point to this point. Okay, so the L, small l, which we have seen previously, so this is the location of old center of gravity from rear axis center. So this line is basically L. Okay, now the new location of center of gravity, which is this from rear axis center, is a small l dash. So this is a small l dash, this is capital L dash. Now this is your wheelbase L, and this is your old center of gravity, horizontal location of center of gravity. Okay, small l. Now this L, it is making angle with respect to horizontal. This horizontal line, this angle is lambda. Okay, so the line joining between uh, horizontal location of center of gravity, actual center of gravity with respect to horizontal, this angle is lambda. Okay guys, so if this is L and this is making angle lambda, so this component will be L cos lambda. Okay, I think you all are aware of this thing. So this horizontal distance is L, small l cos lambda. Okay, similarly we have seen in previous video that this distance was H, the location of center of gravity, vertical location of center of gravity, we have seen it was H. Okay, so this is H. Now you have this line, this is one line. Okay, then you have this second horizontal line. Okay, and this third a small l line is crossing these two parallel lines. Okay, so these are two parallel lines, and this line is crossing these two parallel lines. So this angle will be equal to this angle, and same way this will be equal to this angle. Okay, this is a basic mathematical geometry. You can, I think you all are already aware about this. Okay, so this is h. Again, if this angle is lambda, then this vertical position will be h cos lambda, and this horizontal will be h sin lambda. Okay, guys. So if you see in this perpendicular triangle, then this vertical line will be h cos lambda, and this horizontal line will be h sin lambda. Okay, just listen very carefully what I'm saying. So this is your h sin lambda, this horizontal distance. This horizontal distance is your L cos lambda. Okay. Now this complete thing is the rear tire radius, and this distance is your front tire radius. Lifted it up, then this distance basically the difference between rear tire radius and front tire radius, which we have denoted it delta r. So delta r will be rr minus rf. So this perpendicular distance is delta r. Now again, this vertical distance is rear tire center. So this vertical distance is rear tire center, and just a minute, guys. And you have lifted this tire with n amount. Okay, so this is your rear tire radius, and you have lifted it by n amount. So this will be n minus rr. Okay, so again, if you have joined the line between rear tire center and front tire center, so this angle already I have explained to you. This is lambda. Now this will be lambda 1 and lambda 2. So lambda will be basically lambda 1 plus lambda 2. One more thing is, like this is delta r. Again, same, if you apply geometry, this angle will also be lambda. So this vertical distance will be delta r cos lambda. Horizontal distance will be delta r sin lambda. But if you see this triangle, then this distance will be delta r tan lambda, because tan lambda will be this horizontal distance divided by p by b. If you apply simply, so this is p, this is b, so p by b will be this distance divided by delta r. So this distance will be delta r tan lambda. Okay, guys. Now, uh, as I have explained all the terms which is written over here, now wt, which is the weight of tractor, is acting downward in this case also. Okay, friends. So now in this case, there are some assumptions which has been made. The first basic assumption is, when you are lifting a tractor, there are transmission oils inside the tractor. There are fuel which is situated inside the tractor. So once you lift the tractor, everything will come in this direction, this area. So actually, in reality, those fuel and those lubricating oil and everything will have some impact on the location of center of gravity, which is being shifted. But in reality, we are, for calculation purpose, those fluid shifts which is occurring in tractor, we are ignoring that. Okay, now second case, when you are lifting the tires, your tires actually is soft tires, okay, not rigid tires. So there will be some deflection in rear and in front both when you are lifting a tire. Okay, but for calculation purpose, we are assuming that our tire is rigid. Okay, so these two assumptions has been made in determining the tractor center of gravity. Then second thing is, when you are lifting a tire, you should lift the tire in such a way or by such a factor so that the difference between this r dash f, which is coming in this case, and rf, which was the front tire support in first condition, horizontal condition, there should be significant difference. Okay, guys, there should be significant difference between this rf and r dash f. Okay, so these two you have to take care of. This is the basic assumption, and this is which you need to take care when determining the center of gravity. Okay, now moving forward to derivation. So the first case, you have already seen that we have find out the horizontal location of center of gravity. It was very much simple. Now coming to a tricky part, the vertical location of center of gravity. I have already explained all the terms to you. Now we will move ahead for deriving the formula. Okay, so the first thing is this L dash. I have told you this is the location of new center of gravity with respect to the axle center. Okay, guys. So this distance is L dash. Everything is simple geometry. Just try to follow my cursor and just try to listen very carefully what I am saying. You will understand each and everything. Okay. So your this is your L. I have already told you this whole distance is coming L cos lambda. Then this horizontal distance is coming H sin lambda. So you know up to here it is L cos lambda and this distance is H sin lambda. So your L dash will be L cos lambda, which is this line, minus H sin lambda. That is what I have written over here. L dash is L cos lambda minus H sin lambda. Okay. Now L dash, already you know the derivation of a small l from the previous horizontal location of center of gravity, that a small l is Rf into L divided capital L divided by Wt. So if L is this, then L dash we can also derive like this. L dash will be R dash F into L dash divided by Wt. That is what I have written here. So I have just replaced this L dash thing over here. So it is R dash F into L dash by Wt equals to RHS side is same. Now third equation. Okay. So third equation is for capital L dash. So guys, I have already told you that this is your capital L dash and already wheelbase is this capital L. So from this point you reached up to this vertical point, this perpendicular line, okay, which is capital L. But your small L is up to here in axle center. So you have to add then this delta R tan lambda also. But this delta R tan lambda is not horizontal. Now see, this is L, okay, and this L is making angle lambda with respect to horizontal. So this horizontal component will be L cos lambda, okay. So L is up to here. So if you draw a perpendicular line from here, so up to here, your distance is L cos lambda. Okay, guys, and then this R is making angle lambda with respect to this horizontal vertical. So this vertical line will be delta R sin lambda, and the horizontal component of this will be delta R cos lambda. So the remaining distance this much from this L cos lambda to the rear axle centered is your delta R sin lambda. Okay, guys, so that is what I have written over here. So L dash is L cos lambda plus delta R sin lambda. Okay, now if you take cos lambda common from your third equation, you will get this. Okay, so this is pretty much simple. Your sine by cos will be tan, so it will be tan lambda, and you have taken cos lambda common. Now if you have h in second equation, you know you have h in first equation, okay, and you have value of L dash in last fourth number equation. So if you put the value of L dash in your second equation and you already have first equation, the value of capital small L dash, so from these three you have to find out the value of H. So once you put this all in second equation and first equation, you will find this expression of H. Okay, guys, so you just copy this formula in your notebook and then just put the values in second equation, okay, and in first equation. Basically you can put in first equation, okay, and you will find out this expression of H. So this is actually our vertical location of center of gravity. Okay, friends, so we have seen both the things. First one was horizontal location of center of gravity, small l, and second is vertical location of center of gravity, which is small h. So basically we have derived the expression for center of gravity. Now the term lambda, as I have told you, it is lambda 1 plus lambda 2. Then how to calculate lambda 1 and lambda 2? So if you see this again geometry, this perpendicular triangle, this is n minus rr. This angle is lambda 1 and this distance is L cos lambda plus delta R sin lambda. So you can find out tan lambda 1. Tan lambda is what? P by B. So that is what I have written here. N minus RR divided by L dash. Okay, guys, this expression. So tan lambda 1 is N minus RR divided by this complete L dash. Similarly, delta 2. If you take this perpendicular triangle, then tan lambda 2 will be this delta R, which is P, and what is B? B is again your this capital L, which is your wheelbase. So because you are seeing this triangle. Okay guys, so in this triangle your tan lambda 2 will be delta r divided by capital L. Okay, so this is how we can calculate lambda 1 and lambda 2 and lambda. So if you put the expression of lambda in your second equation or in your L dash equation, you will find this value of L dash. So again, it's up to you which one you want to use. This is how this all is coming. Okay guys, so I don't think there will be any question on center of gravity, because in if you see last 3-4 years, they are not asking any question from center of gravity determination. Previously they used to ask some few questions directly on these formulas, horizontal location and vertical location, but nowadays they are not asking, but you never know if they will ask. So you need to be ready for that. So that's why I have covered this topic also. So I hope that you understood the concept behind center of gravity determination. Now moving ahead, the next small topic is moment of inertia determination of a tractor. So till now we have already assumed the moment of inertia and center of gravity. So center of gravity derivation already we have seen. Now for moment of inertia, so basically first I will try to explain what moment of inertia is. So as you all are already aware that if you have any rigid body or solid body, and if you want to give some angular acceleration, or if you want to rotate that particular solid body about any fixed point, then moment of inertia will help you to determine the amount of torque which is needed to provide a desired angular acceleration or desired rotation to that body about that rotational axis. So this is what moment of inertia is. It is actually a physical property of the body. Okay guys, so in case of tractor also, if this is a tractor and you have just suspended this tractor about this pivot point O, and if you try to rotate this tractor, or if you try to give some angular acceleration to this tractor, then this angular acceleration and the time period of the tractor depends upon moment of inertia of the tractor. So basically simply assume a pendulum, which we all know, we all have studied in our 12th class or 11th class, that time period of a pendulum about any axis t. Okay, so same way we will derive time period of this tractor if you try to rotate it. This is the length of uh, distance of this center of gravity from pivot point, and these two are a string by which you have suspended your tractor. O is the pivot point. Okay, so basically if you know the angular momentum L of the system, and if you have given if angular velocity omega about this principal axis, then moment of inertia will be L by W, L by omega, not W, sorry. Similarly, in other terms, if you know the mass of the body, which is m in this case, by considering it as a pendulum, and if its distance from the pivot point is a small r, then the moment of inertia will be mr square. So you all are aware about moment of inertia. I will be mr square. Okay, so in this case, this is your distance of pivot point from center of gravity, and the weight you already know. So if you know the distance, if you know the w, then you can calculate moment of inertia as w into r naught square. Okay, for this tractor. Now, so what is of our concern in this case is time period. So guys, this will be the time period of this body. T, it will be equals to 2 pi under root I naught by WR. Okay, so I don't think that I need to explain this, because this is a simple pendulum time period kind of thing. So here I naught is the moment of inertia of the tractor plus whatever string or sling you have suspended the tractor with about pivot point O. Okay, then W is the weight of tractor as well as this slings. R0 is distance from this pivot point to center of gravity. So this will be the time period. So if they ever ask any question on moment of inertia, that will be asked mainly on time period. Most of the question will resolve about time period calculation. And second one will be, so you already know I naught, which will be W into R square. Now, if you have calculated moment of inertia about this principal axis. Now, suppose if you have to calculate moment of inertia about any other axis which is parallel to this axis, then how will you calculate it? Again, we will go to basic physics. That will be perpendicular theorem and parallel axis theorem. So we will use parallel axis theorem. So if you have any axis which is parallel to this principal axis, then you can calculate moment of inertia about that axis as I naught minus mt into r naught square, where mt is weight of your tractor, I naught is moment of inertia about principal axis. So this is also a basic simple parallel axis theorem which we all are aware from our 12th class. So these two are actually important in moment of tractor moment of inertia. All the questions which has been asked till now in moment of inertia is basically related to these two equations, either time period or using use of this parallel axis theorem, or basic moment of inertia, which is mr square. Okay, so this is also a topic from which recently in last 4 5 years no questions has been asked, but again you never know when they will ask, so be ready for that. So guys, this is all about center of gravity and moment of inertia. So I think we have reached to a point where I can say that as far as theory part is concerned, this is the end of tractor dynamics. Okay, so I have already explained to you. If you have watched all my videos, all my series videos, just start from tire traction theory and to this tractor dynamics theory, I've explained to you in detail about importance of tire, importance of traction, all the factors which will affect your traction. And then in tractor dynamics, I have explained to you how your weight distribution will change with respect to implement, or with respect to trailer, tractor trolley combination or tractor implement combination. Then we have seen about stability things, and finally we have seen some this tractor center of gravity and moment of inertia. So as far as theory part is concerned, I am done, guys. Now we have seen a lot of things. Okay, we have seen tires, we have seen tractions, we have seen cone index, we have seen Brixius equation, we have seen Wismar and Luth equation, we have seen all the factors which is affecting a traction, we have seen how pull, how slip is coming on the tractor, and how these all things will affect your tractor efficiency. So guys, the most basic questions which comes in our mind is why the hell we are reading all these things? What is the significance of these things? Guys, examination and numerical is one part. Okay, that of course is required. You need to study, and you need to study all the equations to solve your numerical problems. But apart from the numerical, if you just leave aside numerical for some time, then what is the significance of all these things? Why why a tractor designer, or why a student, or why a researcher which want to make any research in the field of tractor or farm machinery needs to understand all these things? Okay, so for that we will go back and we will take a quick recap of what all we have seen, and then we will try to understand what is the significance. Okay, so first of all, we have seen how tire is being made, how tire geometry is coming, how to calculate tractor overall diameter. So this everything has been covered in tire lecture series. Okay, because tire is of immense significance. It is tire which actually helps your tractor to move forward. So if tire and soil is not interacting properly, then you will not get better traction or better grip onto the soil, and your tractor will simply start slipping. And as you all know that slip is simply the waste of power. So you are simply wasting your engine power, and your tractor is not able to utilize that power which is being produced by engine. That is why tire study is of immense importance. Okay guys, now we have seen after that how traction is being generated, or how tire inflation pressure will affect your traction, how different soil conditions will affect your traction, and how to improve your traction, what are the factors by which we can improve our tractor efficiency. Because again guys, if your tractor efficiency is not optimum, if your tire is not able to produce sufficient traction, if your tractor is not able to get sufficient traction, then again you will have more slip. You will have very less drawbar pull available at the drawbar of your tractor to pull your implement. So you will again simply not be able to use your tractor power properly. Okay, that is why the study of traction or the understanding of traction is very important to optimally use your tractor power, and at the same time to uh, to pull different implements effectively in the field. The study of traction is important. Okay guys, after that we have seen in our weight distribution or tractor dynamics series the stability in the static weight distribution. So in this case I have told you this is the RF, which is front support, this is RR, which is rear support. So guys, whenever any tractor is being made in any company or anywhere, initially you have to determine the center of gravity location, and you have to arrange the weight of your tractor in such a way that more weight should come on the rear, less weight should come on the front. Then your wheelbase L will affect this weight distribution. Your center of gravity location, horizontal location of center of gravity, will also affect your tractor weight distribution. So normally, as I have already explained to you, that normal weight distribution will be in the ratio of 60-40. Okay, so in static condition, 60% of the weight will come on the rear, 40% of the weight will come on the front. Normal condition, guys, I'm talking about. This is not a fixed condition everywhere, but normally it is happening like this. Okay, now when you put any implement or when your tractor goes in dynamic condition, then weight transfer will happen from the front to rear, and this 40% will reduce to 20-25%, and at the same time the 60% will increase to 75 or 80%. Okay, now again, if you go to dynamic condition, you know all the forces which is coming. So I have told you this will be the maximum amount of pull which this tractor can take without lifting of front tire. Okay guys, so if you increase your pull beyond this speed, then your front tire will lift up and your tractor will overturn longitudinally. So this tractor dynamics, how weight distribution is happening, this is very important thing from a stability point of view, and stability is related to safety of driver. So you can never ignore, you will never, nobody will ever ignore the safety factor, because safety is the most important part in any either tractor design or for that matter any automobile design. Okay guys, so this is the importance of tractor weight distribution. Without knowing tractor distribution, you will never get to know how much pull you should put on your tractor, or if your front tire is started lifting, then how much weight, ballast weight, which we are putting in the front, how much ballast weight you should put, so that your operation will be stable. Because if you put very high amount of ballast weight, then your overall weight of tractor will go up, and you have to basically, due to this complete weight, your rolling resistance will increase, and due to that your fuel consumption will increase. So, and at the same time, if you put very less ballast weight, then your front will start lifting. Sometime it will lift, sometime it will be on the ground, so the operation will not be very stable. So you see, this knowledge is required to avoid both the things, both the extreme position. So to optimally utilize the tractor and to get better fuel efficiency as well as better tractor efficiency, the knowledge of tractor dynamics is required. Okay guys, now same thing will happen when you are putting the tractor with trolley. Okay, then stability, as I have already told you, stability is related to safety, or anything which is related to safety is extremely important. So again, both lateral as well as longitudinal. If you increase the height of your hitch point, then your tractor operation, tractor stability will be different. If you reduce the hitch point height, your tractor will be more stable. If you increase the hitch point height, your tractor will be less stable. At the same time, if hitch point is high, then you will have more weight on the rear, because you need more weight on rear to get optimum traction. So guys, again, this is a trade-off between traction as well as weight transfer from front to rear. So here again the length of linkage will also play the role. If you have more length of linkage, then weight transfer will be higher, but again your operation will be little bit unstable. So by optimally designing your 3-point linkage or your hitch point, you can utilize the tractor power in a better way. So for a tractor designer, this whole thing is of extreme importance. If your center of gravity location is in, very high, or if your wheelbase is uh, high, then again your stability will be different. If you are taking a turn on any turning, and at that time if your speed is very high, then your tractor can become laterally unstable. Again, this depends upon wheel thread, this depends upon wheel base. So this all things, your lower point linkage length, your lower point linkage location with respect to horizontal or with respect to ground, your hitch point height, your location of hitch point, your wheel base, your static weight distribution, your dynamic weight distribution, everything will ultimately affect your stability as well as your tractive efficiency or your pull which is being generated by your tractor, or at the same time your specific fuel consumption. Okay guys, so these all are interrelated and this all will affect performance of your tractor, and that is why you need to understand these all things very carefully. Okay guys, so this is it, that's it. uh, so I have completed theory part of tractor dynamics. Now in my next video I will explain some of the numerical problems. I will try to solve some of the numerical problems so that you will get even more clarity. Okay, so again thank you guys for watching. If you like the video, then please subscribe the channel, and if you have any doubt, then please just write it in the comment section. I will be more than happy to reply to there. Thank you guys, thank you again for watching.